Good morning, everyone. My name is Lan and I'm from Vietnam. And today I'd like to present my PhD research proposal on groundwater management. So as all of you might know, groundwater is a common pool resources and it is depleting in both quantity and quality in all over the world. Australia is not an exception. Given the significant depletion of the groundwater resource, the question on how to manage groundwater more sustainable becomes a concern for many, not only water regulator authorities, but also many scholars such as economists and environmentalists. So today, in this PhD project, I will study focus on studying the impact of externalities in groundwater management and the instrument to reduce this negative impact of externality to manage groundwater more sustainably. More specifically, I will study the groundwater problem in Western Australia, the impact of groundwater extraction externality for Gnangara Mount in Western Australia, how do this impact change depending on the groundwater resource condition, and to identify which instruments are most effective to reduce this impact. In Western Australia, Gnangara Mount is the largest groundwater system, providing around 50% of Perth's drinking water. It also provides water for agriculture, for public irrigation, industries, and for wetland ecosystem. And the water level in Gnangara Mount is declining over time due to the over-extraction, the over-allocation, and due to climate change. Therefore, the government of the Western Australia is seeking for the solution to reduce the water extraction from users. There are many types of different users of groundwater. However, in this research, I will focus on the agriculture sector and the farmers who are the second largest groundwater users in Western Australia. So externalities have been identified as one of the factors that hinder the sustainability in groundwater management. And there are many types of externalities associated with groundwater extraction. In this research, my focus is on the two main types of externalities, which is pumping cost externality and environmental externality. In the literature, these externalities have been studied under the assumption of bathtub aquifer, which assume the water flow, the recharge, and the discharge uniform regardless locations. But in reality, this is not the case. In this research, I'm more interested in studying these externalities under the spatial configuration of the aquifer. And so the pumping cost externality in a spatial configuration of aquifer is defined as follows. So when user 2 pump an amount of water, resulting in the reduction of water for user 1 and user 3 at the same aquifer. And consequently, user 1 and user 3 have to increase their cost of pumping to extract water. But however, the water extraction from user 2 impact differently on user 1 and user 3 according to their location. The user 3 is closer to user 2, and so that's why he suffered more impact from water extraction from user 2 and have to pay more to extract the water in the future period compared to user 1. And without the management, all groundwater users will try to extract as much water as possible to avoid the increase in cost of pumping in the future. And this will lead to the tragedy of commons and depletion of the groundwater resources. The spatial configuration of the impact of spatial configuration works the same way for the environmental externality, but the environmental externalities refer to the external impact of the groundwater extraction users on the ecosystem. Given that there is a strong interconnection between the groundwater and other ecosystems. So if the groundwater is over-extracted, there will be a lack of water available to support the ecosystem, and then they will cause habitat loss, reduce deaths of animals and plants. And the cost of recovering the ecosystem could be huge for the society. So there are several approaches to manage groundwater externalities. The first traditional approach involved an intervention on the price of groundwater. However, pricing a common pool resource such as groundwater is often challenging because groundwater is a complicated and invisible resource. And this also results in inequality because the rich farmer can extract more water than the poor. The second approach is quantity driven by the regulators, and this is a common approach that is used in many countries currently. But in many cases, this does not work very effective. The groundwater is often over-allocated because of the uncertainty in estimating and identifying the sustainable allocation limits. Sometimes the users are extracting more water than they are allowed. So there is a third approach, which is also influence the quantity of groundwater by not only regulator but also by users themselves. This approach engages more directly with the users and try to influence their behavior in reducing water extraction. This two-quantity approach wouldn't work effectively without a proper monitoring and enforcement scheme. The monitoring and enforcement can be run from top down, can be run from regulator, or also by users themselves. Some existing gaps in the knowledge in the literature regarding the study on externalities. First, the impact of externalities have been studied globally, but to date there is none in Australia. Second, existing studies of externality did not capture the user's behavior comprehensively. Only few studies focus on the user's behavior, but only on single type of externality, not multiple types of externality. And also, there is a lack of understanding on users' behaviors under different monitoring and enforcement regimes. So I will fulfill this gap by using optimization method and economic laboratory experiment. The first method is to identify the size of impact of multiple types of externality in Western Australia. The second method is to capture user behavior under different management regimes to identify the most suitable one to minimize the negative impacts of externality. So, in the optimization method, I will develop a model based on the study of Esteban and Dina in 2012. The model is, let's assume that the farmer wants to maximize his farm profits. He will select a crop so that it brings a good revenue, reduce and consume less cost of input and consume less pumping cost. The pumping cost will depend on the total water requirement for the crops that he selects and the current pumping height. And the farmer's constraint is a drawdown of water level in his well, which is defined by the spatial connectedness. The spatial connectedness involves some elements such as storativity and transmissivity, the distance between wells, and the pumping rate of neighbors. If the farmer cares about the impact of his pumping on other neighboring wells, he would want to internalize the pumping cost externality. And similarly, if he cares about the impact of pumping on the ecosystem, he will want to internalize the environmental externality on his objective function. So the spatial connectedness influences both two externalities. And there are two factors that could influence farmers' decision on internalizing the externalities, which is the pumping height and the distance between the wells. For example, if the water level in his well is too low, he might be afraid that he doesn't have enough water for producing the crops. So then he wouldn't care more about his pumping impact on whatever, like on other or like on ecosystem. At the same time, if his wells if the density of the wells in the aquifer is very high, his drawdown of water level would be more significantly reduced by other neighbors' pump, and if he does not increase his pumping rate, he also cannot have enough water for producing the crops. And this behavior will be captured in an experiment, a laboratory experiment for the research question 2. So as mentioned earlier, there are two factors that affect the farmer's decision on internalizing externality, which is pumping height and distance between wells. That's why in this experiment I will design combining the variation of these two factors to study the joint effect of the externalities. Observing the combination of behavioral in each combination will give an idea of in which situation the farmer will extract more or less water. And for the research question 3, I will also use laboratory experiment to study the management instruments. The first one, the allocation limits one, is the one that Gnangara is currently using to manage the groundwater. The second one it was suggested in the literature to reduce the pumping cost externality under the spatial configuration of aquifer. The third and the fourth are to reduce the impact of environmental externality either by regulators or cooperatives. And with all of this management approach, I will test under different monitoring and enforcement schemes either by regulators, cooperative, or no monitoring. For the data collection, for the first research question, I will just use the existing data from the website, statistical portals of the government, and the research question 2 and 3, I will collect data from experiments. And this is my work plan.